Today we have a lunch lecture by Blitta. They are going to tell something about the Berghaus Plaza. It's a project in Amsterdam, and Harold is eager to tell you a bit more about it, so I would like to give the word to him.
Good afternoon, everyone. I hope you enjoy your sandwich supplied by Geops. My name is Harold Kok. I'm doing a bit of sales engineering and project engineering for the Blitta. I want to give you a warm welcome, and I'm really glad that there are so much people interested, and I hope that I'll give you an interesting enough story to make sure that at the end you're still here. Okay, let's kick off. You see here the nice project from Berghaus Plaza. What I want to do in this story is that going to tell you a little bit about our company, what we normally do, and what our advantages are above the competition. And then we will start, and I will try to take you along in the journey, the story, how we developed the project and which things we encountered and which design solutions we made to make the building possible. Okay, one of our strong points for our company is that we are very tied onto a specific project, and that means that we're making tailored profiles and even the mounting for the gear that we need. We develop special tools. The project that you see here is the Province House of Antwerp. And you see those nice triangles here, and they look nice and cozy, but you have to take in mind, as you can see in the picture here, they are from floor to floor. So that is a triangle approximately 3 by 3. And it's on an angle on the facade, so there was a lot of challenges we have to overcome. But that's what we like to do, that's where we're best at. As I told that we are a facade specialist for special facade constructions. In the background you see the project The Valley. I think it's certainly known, it's an award-winning skyscraper. As you can see, it's a very complex facade, and it's in a high rise, so that also gives some other challenges due to water tightness, air tightness, security, fire, and so on and so on. We have an annual turnover about between the 20 and the 30 million. It's a little bit depending on how the project market is developing. At the moment, everybody knows we're a little bit in a rut due to the high revenue we have to pay on our loans. So, it's a little bit in a rut. We are about 110 people big. That means that we are not a very, very, very large company, but we are somewhere in the middle. But we have a very capable people working with us with a lot of know-how, going from up to the board to the work floor, and we use each other's knowledge and experience to enhance our projects for the future. The markets that we serve are the Dutch market and sometimes a little bit in the Belgian market. The last previous project that I showed you was in Belgium. And what is our strong point? We do a total solution. We do not only deliver the facade, but we want to make a whole concept for the membrane skin of your building to make sure everything connects on the right order and is on the meets the demands, the requirements architecturally, but also legislationally, to make sure it's up to specs. In that part, to get that, we use a lot of product development, as you saw on the previous picture with the nice triangles. That's not something that you can buy by Schuko or Kaunier or Vicona or whatever. That's something that you have to make up yourself to make sure it works. A thing that is becoming more important is the sustainability. I will show you a few slides ahead. I'll show you a project where we achieved that yeah, by doing things smart. We do everything in BIM, and not only for a model to see how nice it looks, but we also use the elements in the model for the machines in our production. So we don't only make a nice 3D element, but everything is accurate in the element. So who buys by us knows exactly what he's going to get. And in the facades that we use is mostly unitized curtain walls. I will explain later what a unitized curtain wall exactly is. One of the advantages from a unitized curtain wall is that you can make a prefab panel and just build your complete building, including the aesthetic layer that you want to add onto your curtain wall. So you can see that we are a one-stop shop because we do a total solution. And yeah, as I already said, custom-made products. You see here another awkward Amsterdam school Urker style construction. Yeah, of course, sustainability. Lots of photovoltaics were hot a few years ago. And this is Hoog Catharijne project. This is the entrance of Hoog Catharijne Utrecht. That's the first project that we completely did in BIM. And from which year was Hoog Catharijne again? You should know, Tiziano. Yeah, about approximately 7, 8 years ago that we developed that. And we did a complete production model in BIM. This is where you can see the prefabrication, where we have made a facade system where you can add on the aesthetics. This is also circular. If you want to change the look and the feel or enhance the installation layer, it's easily done, because if you make it prefabricated by modules, you can also detach the module and apply another module if you want to. So that makes it nice. Yeah, here we have a Maaswaard Venlo that's near our production plant. It's a residence project with a lot of photovoltaic elements that we applied in the unitized curtain wall system. This is another highlighted project. This is Lab 42 from the University Amsterdam. What's the specialty about this project was that normally when you have a unitized curtain wall, you start stacking from the bottom, and you go layer by layer up into the air till you reach the roof. This one was built upside down. We started at the top and built it down. And the beauty of it is that it's circular. You can detach any element you want, take it out, and use it in another building that has less requirements in the future, or you want to upgrade it, you need more soundproofing, or you want more insulating values. You can just pick any element you want, you can pick out. For the idea, when they were building it, and the total building is circular. You can take everything apart and rebuild it somewhere else. It's just like a tent or something, Meccano box like. They made a little mistake by pouring the concrete floor, and the facade was finished, and we took out 3-4 elements. They repoured the concrete, and after that we put the existing elements back in. So it makes it a very versatile system and in the circular thought, so that's real nice. Now we're going to what the story is all about, and that's Berghaus Plaza. That's also in Amsterdam. It's near a project where we had a project visit with GEOPS Oku House. I don't know if there are any people who went to Oku House together with us. You missed an opportunity to see how it is working on site with unitized curtain walls and prefabricated elements. The Berghaus area is an area which used to be light fabrication and offices resident of area. And what you see in the city of Amsterdam or Rotterdam or any big city, you see that the old industrial parts getting redeveloped for living, because we have a very high shortage of living space. when we're looking at this project, there are a few main things that are I want to discuss later on in this. This is a little resume what we're going to discuss. I want to start with the redevelopment of the Berghaus area, and then we're going to go into the Tower 1, and it will be more clearer. This is an office building, because like all the projects that we do now, we have living, working, leisure all together in one building, or in a building group. So we have the offices. Then we have the heritage facade. Oh, where's my light? The heritage facade, I will explain why it's a heritage facade. And then we have the residential towers 2 and 3. And I will tell you a little bit about a problem that you have in Amsterdam is you have a high sound, you have much noise on the outside, and you want to ventilate, but you have to keep it rather quiet on the inside, the 30 and the 35 decibels, depending on if it's a traffic or another room. So where did Berghaus started? Berghaus started as an old building. You see here on the left. They wanted to redevelop. They had a few choices. The most easy thing is to smash the existing building to the ground and build something completely new. But the municipal of Amsterdam decided that it was kind of a heritage for the area. So they want to keep the features, the design features, certain design features. Because back in 1882, Berghaus is a fashion trademark, and they wanted to build something in Amsterdam to make prototypes and personalized clothing. And in '64, they realized their first atelier at the Berghaus, and it's called the Berghaus Plaza Fashion District. And you can see the building here. And the municipal of Amsterdam thought that they want to keep a little bit of the view that they have there, because architectural is quite important. It's typical 1960s, straight, because we didn't have CAD/CAM and BIM and other beautiful parametric programs that can make fluent lines. We had a drawing board, and we have to do all with the ruler and a pencil. So you can see that it's all quite straight, but still they tried to make it a kind of a business appearance. And for the time in the 60s, this was very, very modern. Now we would say, okay, it looks like Russia. A little bit East Bloc. What they had is clean straight lines, and they had a unique recess in the facade. I will show you later on what it is. And what they did for the development, to keep that heritage, the architect rebuilt the first layer, and that's this part of the building. It's a rebuild, so it's not overhauled. They really tore it down, because, yeah, you will have things with the legislations and demands that you have, the modern demands you will never meet with an old building. And what he did is he stacked the extra functionality, he stacked just on top of the existing looking building. So that's what he did. And that made us divide this project in a whole lot of different sections. And every part that you see in the color is a different section for us and another product type. And I'm going to take you on a journey from which product type, why we chose it, how it looked, what was the design features, and what was the design solution. You can see the office here, it has two colors. It is partly in unitized curtain wall and in traditional curtain wall. I will explain why. We have the monumental facade heritage. I will show you also. We have an example of it, a mock-up example over here. So if you want to look up close, how it in real looks instead of a nice drawing, you can look and feel if you want. And I will tell you a little bit about the resident blocks 1 and 2. First, we're going to start with the offices. Um, like I explained, we split it up in two parts, the yellow and the green one. And the left and right side of the building, they are very repetitive. That means there's no lot of diversion in the lines, in the measurements, and also not in the technique that you want. At the front, you can see there are a whole lot of other things going on, and on the other side it's even worse, which a unitized curtain wall isn't the perfect product for. When you take a unitized curtain wall, and I just put on an example of it, you see that we have a system that spans between two floors. It's used for the total builder's skin, so you can make a complete cladding of it for your building if you want to. It's a prefabricated solution. That means that we make it completely in the factory, and it's just like a little picture that you want to hang on the wall, and that's how we stack our buildings. So it's very simple. Yeah, it's easy because you can do a lot of things in your factory site. When you go outside right now, if you want to glue two pieces of paper together, you will not get it done. And here is a piece of cake. And that's the same for prefabrication. You have a controlled environment. So your adhesives will work. The grooves where you put your EPDM profiles in, your gaskets, are not cluttered up with sand and dirt and other sort of things. So that's why we want to prefab. You go into a building, when you go into big city building state of building areas right now, redevelopment, there's a lot except for space and time. It's mostly crowded, and you want to be able to say, okay, let's make it a prefab element, put it in a crane, stack it on the building, straight out of the truck, and when it's hanged, take the next one. It goes fast, and you don't have a lot of stress on the building side due to time. And what you see here is one of the elements of the Berghaus Plaza that we are making, and this is how we stack the complete facade. And we stack them on top of each other, and we anchor them on the floors. One of the advantages is also that you have a very high performance of the element, because you made it prefabricated in the factory. The environment is right, but also the system is made specially developed for high rise. So 1200 pascals are in the range of the system for air and water tightness if you want to. Another part, and it's a big advantage for us, when we develop something like that, we're trying to make all the Lego blocks the same, because it's product optimization for us, saves us a lot of time. And the aesthetics, we can always change that as a second layer. So it looks different, but for us, productionally, it's almost the same. What a design solution is, you saw at the picture of the facade, and I will switch quickly to the next one. You can see that we have floor bands that are going across every floor. And we want to make a prefab, so we have to make a solution that we don't have to put in the facade and add on the floor bands and the aesthetics later on. We want to take that as a whole. So what we did is we integrated the floor band. This is the floor band that you saw in the picture. And we integrated that on our element. But that gave us a little difficulty, because the level of the floor band is not the same as the actual floor is. So that meant that the top element, we had to make a recess so it stacks and overlaps the previous element. And that makes it a little difficulty, because you have to take in mind wind loads and weight and kind of things. As you can see here, the facade elements and conventional curtain wall for this part, and now you can see it's even a little bit complicated, more complicated on the other side. And that's why we chose for another system. And we used the traditional curtain walls, and that's the stick system. And what's the advantage of a stick system? Is yeah, it's very common in use. Everyone knows it. It's an element you can choose to put between floors or in front of several floors. It's also for your total building skin. You got complete buildings that are made from the traditional curtain wall. Where you, most of the times in buildings nowadays, you find them on the plinth. Because that's a part of the building you want to keep open due to your building process for the logistics that you need. Stuff that gets in, stuff that needs to get out. And curtain wall is something that you assemble on the building site. And that makes it a very flexible construction, because you start with the sticks and then you start to put in your fillings. And yeah, if necessary, you can adjust or even change on site if you really must. Preferably not, but you can. There's one big backdraw on this. It takes a very long lead time because somebody is really assembling part for part on site, so it takes a lot of time. Everyone knows an IKEA chest or a chair or whatever. It looks very simple, but when you start assembling, the 2 hours and you hope you have something. And that's the same for a curtain wall. It's very easy, but it takes a lot of time. And there are a lot of handlings with gaskets and glues that you have to do on site. And that makes it, you need experienced people to make a stick curtain wall on site. So why did we choose it here? Because it's very versatile. You can change, you can make difficult corners. If you have good personnel, you can adjust the gaskets if needed, if it's different than we predicted or made up at the drawing office. So that's why we chose there for a conventional a curtain wall system. And it also has to do with those nice rounded corners that we have. You saw the building here, that we have nice rounded corners, and they look awesome, they really look awesome. But there's one downside to things that are bent. The dimensions of the prefabricated stuff that you get, the tolerances are much bigger than that you normally work with. And when you have a circle radii, and the radii diverts a little bit, and you try to stack it on one that's nice on spec, it will not fit. It will go open, or it will, at the ends, you have to bend it to make it fit. And with a curtain wall system, you glaze from the outside. There's a little bit of the detail, so you come with your glass pane, and then you can fix it, and then you can put on your pressure plate, and you can screw that nicely till it fits and gives not too much stress on the glass. So that's why it's a more suitable system, though it takes more time and it needs more expertise on the building side for the people who are mounting the facade. You heard me talking. We had a mix between a unitized curtain wall system and a more conventional curtain wall system. So we had to make a design where we can seamless go from the unitized curtain wall to the curtain wall. Someone who does not know it are two different systems, completely different systems, will not notice from the outside, and from the inside also will not notice. That means that we had made a unitized curtain wall system with the floor band attached prefab, and we have to make the same detailing and also apply the same profiles for the floor band to make the aesthetics check up and make sure that everything aligns with each other. And that was kind of a challenge. Then I want to talk about the monumental facade. As you saw in the previous, it's an heritage from the 60s. And one of the design features is also that you see those yellow vertical lines. Those recesses had to be kept in the new design. But in the 60s, nobody give anything for insulation. They use single glass units, for example. Why use two? It was expensive, and gas is cheap at the time. So if you make a recess in a profile, your insulation line of your glass, this is your glass, and as example, we have here the transition post between the insulated and the uninsulated. But if you imagine both were insulated, your ideal thermal line would be this one, straight through the spacer of your glass. When you make a recess, you make a jump in your thermal line. For water tightness or insulation, if you make a jump, automatically means problems. Or at least you got to watch out not to make a mistake. That was also the big challenge. The water tightness level we put back onto this level here. We have a horizontal gasket that connects with this one, and it makes sure that water is allowed up to here, and then it will be moved out of the system by the shape of the profiles. Let's see if I get that other one. Yeah. This is the gasket, the closing line that we had, and you can allow water to here, and then the vertical gasket will connect to this one, and your water will be nicely lead out of the system. To make sure that we didn't make a mistake, we had the profile supplier that we used in a little bit of co-designing, because we know a lot, but we cannot know all. And we need some guarantees also. Everyone who buys something wants a guarantee. So we asked our profile supplier to make a thermal calculation. And this is really a thermal calculation. It says nothing about the U values or whatever. It's pure made to make sure we don't have condensation on places where we don't want to have condensation. You can see this red ISO line. And this red ISO line is the temperature line where condensation will appear at a relative air humidity of 50–55%. If you have a higher humidity, the temperature, the line will shift up. And if you have less, it will shift down. But as you can see in the solution that we made up for this project, in normal circumstances, we don't have a problem with it. So if you have a deviation in your thermal lines, and you have the luxury, someone who can calculate in Trisco, Bisco, or whatever, do it. And not for the U values, but especially to make sure you don't have condensation. And also in renovation projects, these are very high risks, because you have insulation lines that are in a barrier that you normally will not expect. You try to put the insulation in the middle and not on the inside. But in renovation, you see a lot of insulation on the inside. That means that all the water vapor is also on the inside and cannot get out. So they will have problems if you use wood and kind of stuff. Oh yeah, just like I already told. This is the single plane and the thermal challenges, as I just explained for this. And also, for this unitized curtain wall, we have the great advantage to make everything prefabricated and to stack them. We have a little example here from a unitized curtain wall. So if you want to experience how the system works with stacking, you can come over here after the lecture and ask us some questions and have a look and feel. Yeah, the same advantages as I already explained by the previous curtain wall. Yeah, prefabrication, short lead times, controlled environment, and so on and so on. So now we're going to the domestic. Domestic towers 1 and 2 are domestic, so it means it has to be cheaper when you have office spaces, and so you will see that your investor will be willing to put more money in it than when he's going to build a residence, because the revenue, the turnover on a residential space is less than when you have office space, depending on the location where you are, of course. That back in my town, I think it's the other way around. But in Amsterdam, they know their prices. What we did is a timber frame construction, and we used the different window and door elements, and we put them into the timber frame construction. The idea is to make the timber frame construction at the timber frame construction supplier site. We make our elements, and we're going to build them in the timber frame construction at the fabrication site of the timber frame constructor. That means that we do not have to mount it at the building site, which is a big advantage because you have the same advantages as you have a unitized curtain wall. You can prefabricate everything, and you can do everything in a controlled environment. There's one but. That means you have more than one party making one product. Your product is this what you see hanging in the crane, and this is what you want to buy as investor or as building contractor. But there's someone who made the timber, there's someone who put on the stone strips, and there's someone who made the aluminum windows, doors, or whatever you needed in them. And that means you will have a problem with the demarcation. Demarcation means which party does what and is responsible for what. And when you tear it down, it's very obvious who is responsible for which part. This is the timber frame construction. The one who makes that has to put guarantee on it. You have the cladding supplier. You have the window supplier. But where it all comes together, so that is this area where the mounting on the timber frame construction is taking place, you puncture any kind of membranes that you put onto your timber frame construction. And if there's a leakage, who has done it and who's going to pay? That's the big question. So it's a more riskful operation than going for a unitized curtain wall system, because then you have a one-stop shop, and this is not. Other things is that you need to take in account is that every supplier has to synchronize his production or build his stock with the one who's leading in the lead time process. And that's also possible. We have done that for a few projects, but it will take a lot of synchronization and a lot of talking to get it right, and also to make sure the risks are covered. What happens if one is too late? Because it will stagnate the complete production of the one who's leading in the story. So this is an outcut from the domestic. Now you see it a little bit closer up, and you can see this. We try to make our elements into the timber frame construction and make it as a one unit. But unfortunately, yesterday I heard that the main contractor didn't thought it was the best idea, so we are still installing them on site, but pre-glazed. So it's a little bit in the middle between conventional and prefabricated. There's another specialty in this building. When you were building in Amsterdam, you have a lot of traffic, and you have demands on sound reduction, but still you have to get your ventilation quota. So it means if you have a part that you can open, you will have the air in, but also the sound. What we have developed for that is the so-called harbor fenster. I don't know if anyone knows what a harbor fenster is or is common with the name. No? Okay, a harbor fenster is very easy. What we do is we put a window that has the thermal properties and the wind and air tightness properties that you need to reach due to legislation and what you have decided in the contract. And it has an opening part. It has a window that you nicely can open, so you can ventilate when you need to. What we did is we put a barrier in front. That's this window, and it's not insulated, so the thermal line is in this detail going from there to there to there. And so this one can be not insulated, so it's cheaper to make, and it costs us everything, of course. When you make a cross-section of it, and I've taken the two separate elements, and when you make the cross-section, you can see that when you put your ventilation open, the air will go in, and it will bounce, and it will be absorbed by absorbent material that we put in the sides of it. So you can reduce sound and still ventilate. The amounts of reduction is about 14 to 18 decibel. It's not very lot, but it's enough to meet the demands for what they call in Amsterdam the dove gevel. So you don't have to make sound loggias and all other kind of more expensive parts. You can easily solve it by putting in a double window and get your ventilation and your sound reduction at the same time. I'm almost at the end of the story. I give you a little walkthrough how we approached the project and roughly what we had to, which challenges we had to face and we solved. The nice thing is that we have planned a visit for the building site. The building is now under construction at the 13th of March. And if you want, you can, you can ask by Geops if you can come along. Just like we did last year to Berghaus Plaza. And I want to thank you for your attention. This was the lecture for now.
Yes, thank you all for joining. Thank you for giving the lecture again. You can scan your My Future points upstairs at one of the committee members, and hope to see you at any future activities of GEOPS or at the activity with Blitta in Quartal 3.